Hello everyone. In this lesson, we are going to use the rectangular approximation method to approximate the area under the curve, and that is the definition of the integral or the antiderivative. There are three ways to approximate the area under the curve. Left endpoint approximation, we choose the left height of the rectangle. Instead of right, we choose the left. So we chose A as the height of the first rectangle. For the second rectangle, the left endpoint is x1. So we choose x1 as the height of the second rectangle. For the third rectangle, we choose x2. And the fourth rectangle, we are going to choose x3 because x3 is the left endpoint of the rectangle. Now, if we add these four rectangles up, the area is going to be a little bit less than the actual area because we are leaving out these four little triangles, these four little pieces. So this is an underestimation if we use the left endpoint. To use the right endpoint, we are going to use x1 as our first point. This is the right endpoint, right next to A. The right to A is x1. And for the second rectangle, we're going to use x2 instead of x1 because x2 is the right of x1. And similarly, we can use x3 as the height for the third rectangle. And for the right endpoint, we're using B because B is to the right of the rectangle. So now if we add up these four rectangles, this is an overestimation because we're adding the little pieces extra when we do a right endpoint approximation. The third rectangular approximation method is going to be the midpoint. We're taking the average, adding the left and the right, and divided by 2 to get the middle point. And this is a better approximation because we are not throwing the little pieces away when we do an underestimation, or we're not adding the little pieces each time we find a area of a rectangle. So basically, we're taking the average of the left and the right. For the midpoint of the first rectangle would be A plus x1 divided by 2. That would be the height in the middle. And for the second rectangle, that would be x1 plus x2 divided by 2. That would be the midpoint of x1 and x2. Second rectangle. The third rectangle would be x2 plus x3 divided by 2. That's the midpoint of x2 and x3. And for the fourth rectangle, that would be x3 plus b divided by 2. So that would be the midpoint between x3 and b. So that is the average of the two endpoints. Now let's do example number 1. In example number 1, we are trying to look at the area under the curve using 4 subintervals. That means 4 rectangles of equal base. So the base is going to be delta x, which is from 0 to 1. So we take b minus a, and we want 4 rectangles, so we divide it by 4. So that's going to be 1 minus 0 divided by 4, which is 1/4. Let's look at the picture over here. First endpoint is 0, and next endpoint is 1/4, 2/4, 3/4, and 4/4, which is 1. Now, to use the 4 rectangles to approximate the area under the curve, we start with 1/4 is the base times the height, which is y of 0. The next rectangle will be the same, base times height, 1/4 times y of the next endpoint, which is 1/4. So we're using left endpoint, we're using 1/4 as the height of the second rectangle. And the third rectangle would be the base again, 1/4 times the height. Now the height, we are using 2/4 as the height, which is the left endpoint. So 2/4 or 1/2. And the last rectangle, which is the fourth rectangle, base times height y of 3 over 4. And that is the left endpoint of the fourth rectangle. Using the left endpoint approximation, rectangular approximation, we will get 1/4 times 0 plus 1/4 times 1 over 4 square plus 1/4 times 2 over 4 square. We're keeping denominator the same so it's easier to add at the end. So 1/4 times 3 over 4 square, that's the height of the fourth rectangle, and 0 times 1/4 is 0. Let's factor out the 1/4 to make the math easier to do. So we have 1 over 16, take 1/4 out, and here we have plus 4 over 16 plus 9 over 16, and that is 1/4 times 14 over 16, which is 7 over 32. And that is the approximate area using the left endpoints. To approximate the area under the curve using the right endpoints for a rectangle of equal base, we start with x1, which is 1/4, and x2, which is 2/4, and x3, which is 3/4, and x4, which is 4 over 4, equals to 1. Instead of using A, we're not using A, we're using the right endpoint. So we have a little height, which is 1/4 square. That's the height, and the base is still the same. So our delta x is still 1/4 because we divide 1 into 4 equal spaces. So the first rectangle is 1/4 times 1/4 square. The second rectangle, we are going to use 2/4. So 2/4 is to the right. So our rectangle is going to be 1/4, which is the base, times 2 over 4 square. The third rectangle is 1/4, the base is 1/4, times 3 over 4 square. So 3 over 4 square is to the right of the rectangle. So we're choosing 3 over 4. And the last rectangle, which is base times height, base is 1/4, times the height, which is 4 over 4 square. Now we multiply and add. We get 1/4, factor out the 1/4, all bases are the same. 1/4 square, 1 over 16, plus 4 over 16, plus 9 over 16, plus 16 over 16. Now we add all the numbers. We get 1/4 times 9 plus 1 plus 4, which is 14, plus 16 is 30 over 16. So when we cancel, we get 15 over 32. And let's put in square units because it's an area under the curve. So we say square units. Our third method of rectangular approximation is the midpoint. So instead of using either 0 for the left or 1/4 for the right, we are using the midpoint between 1/4 and 0, which is 1/8, 3/8, 5/8, and 7/8. So our midpoint rectangular approximation using 4 equal base rectangles are 1/4, which is delta x. We're using the same base, delta x, but the midpoint is 1/8 square, plus 1/4 times 3 over 8 square, plus 1/4 times 5 over 8 square, plus the last rectangle, same base, 1/4 times 7 over 8 square. Now factoring out the 1/4 because they all have equal bases, take out the 1/4, we have 1 over 64 plus 9 over 64 plus 25 over 64 plus 49 over 64, which equals 1/4 times 84 over 64, or 21 over 64 square units. And as we can see, this is the better approximation because when we draw the midpoint of the height of a triangle, we get a better approximation because we are not throwing away an entire piece or including an extra piece. We're taking the average of the two. So the midpoint is between 2/4 and 3/4 is 5/8, and we're taking the average of the left and the right endpoints. And 7/8 is the midpoint of the 4 rectangle, and that is the average between 3/4 and 4/4. Now you try example number 2 using the left rectangular approximation method, the right, and the midpoint. And remember, delta x is the base of your rectangle, and the base is 2 minus 0, or b minus a, divided by 4 subintervals, which is base equals 2/4, or 1/2. When you're done with your calculation, I would like you to answer this question. Is the left rectangular approximation method always give you an underestimation for all functions? And explain your answer. Good luck on your homework, and I will see you in the next video.